All right, we have lesson 5.5, inequalities involving absolute value. With an absolute value with an equation, we solved for a positive and a negative of what it was equivalent to. Well, here with absolute values and an inequality, we're going to do something very similar. With a single inequality with an absolute value, it is representing the distance between x and 0. So let's first look at example 1. With an example 1, we're going to have the absolute value of x is less than 3. So what this is telling us is that the distance between x and 0 is less than 3. So I can start at 0 on my number line and go 3 units to the right and 3 units to the left, and I know that that is going to include all values that make that true. So if I look here, that inequality tells me that x is greater than negative 3 and x is less than positive 3. So we can write out the solution here as the set of all numbers x such that x is greater than negative 3 and less than positive 3. All right, so notice that any value between negative 3 and positive 3 will make that inequality true. Okay, let's look at example 2. Example 2, we're going to solve and graph the absolute value of m plus 2 is less than 11. So just like we solved regular equations with absolute value, we set one positive, so we have m plus 2 is less than 11, and then we set one to the negative. So we're going to do the same thing. We have m plus 2, and it's going to be set equal, in this case, to a negative 11. However, when we set that to negative 11, we have to switch or reverse our inequality symbol. So instead of it being less than, it is now greater than. Okay, so over here, we're going to go back and solve for m by subtracting 2 on both sides. So we have m is less than 9. And over here, when we subtract 2 from both sides, we're left with m is greater than negative 13. So now we have two solutions to put on our number line. The set of all numbers m such that m is greater than negative 13 and less than positive 9. Okay, so we're going to put an open circle at negative 13 and positive 9, and it's going to be all numbers greater than 13 and less than 9. So that includes all values between negative 13 and positive 9. Okay, so let's look at our next example. We have example 3, and we're going to look at the absolute value of x is greater than positive 3. So this is example 3. Okay, so very similar to x, the absolute value of x is less than 3. This is the distance between x and 0 is greater than 3 this time. So if I look at my number line, I can start at 0 and put a open circle at 3 and an open circle at negative 3. But instead of having the values that are between the two, x has to be greater than 3 units from 0. So it's going to include all the values greater than positive 3. So x is greater than 3. And all the values less than negative 3. So x is less than negative 3. So then we have our solution to be the set of all numbers x such that x is less than negative 3 or x is greater than positive 3. So instead of putting a compound inequality here, we have to use an or statement to show that x can be less than -3 or greater than +3. Okay. Let's move on and look at example 4. In example 4, we have the absolute value of 3n plus 6 is greater than or equal to +12. So just like we did before, we're going to have two possible choices for this, for our answer. So we're going to have 3n plus 6 is greater than or equal to +12. And we're going to have 3n plus 6 is set to -12. And just like we did before, we have to reverse the inequality symbol. So instead of greater than or equal to, it's now going to be less than or equal to -12. So when we solve for this, 3n plus 12 or plus 6 is greater than or equal to 12. We're going to subtract 6 from both sides. That gives us 3n. It's greater than or equal to +6. Divide both sides by 3. And n is greater than or equal to +2. On the other side, we're going to subtract 6 from both sides. That leaves us with 3n is less than or equal to -18. Then divide both sides by 3. And n is less than or equal to -6. So we can write our solution as the set of all numbers n such that n is greater than or equal to +2, or n is less than or equal to -6. Okay. So we need to put an open circle at -6, or a closed circle. We have less than or equal to. So we have a closed circle at -6, and n is less than. So it's all numbers less than -6. And then we have a closed circle also at +2, and n is greater than. So we have all values greater than +2. So this tells us that x cannot be any value between -6 and +2. But it can be larger than those, and it can include 2 and -6. Okay. So on your own, I want you to practice these two problems and have them ready for class tomorrow.